So let's begin then. So we need to convert 2/9 to a decimal. We have to convert 2/9 as a decimal. So how do we do this? So we know that 2/9 is the same thing as saying 2 divided by 9. It's the same thing as saying 2 divided by 9. So we're going to do 2 divided by 9 and we're going to write this as a decimal. It's going to be 9 divided by 2 like this. And we're not some 0.000 as we know that's going to be a long decimal. Now what we're going to do is that we are going to see if 9 goes into 2. 9 goes into 2 0 times, going to carry up to 2. So it's going to be 9 goes into 22 times, because 9 times 2 is 18. The remainder is going to be 2. Then you'll see that's going to keep on going. It's going to be 0.2222222. Now we can write this as 0.2 recurring. We're going to put that sign above that. 0.2 recurring like that. And that will just be your answer, okay? So we need to convert 4/11 to a decimal. It's going to be the same process. We're going to do 11 divided by 4.0000, then yeah. So 11 goes into 4 0 times, and then we carry the 4. Then 11 goes into 43 times, because 11 times 3 is that 3 is going to be remainder 7. And then 11 goes into 76 times, and then we know that remainder is going to be 4, so going to be 3 here, and then it keeps on continuing like that. So it keeps on recurring. So then we write this as 0.36 recurring like this, okay? 0.36 recurring. And remember to always put the dots in on top of those numbers that are recurring, like that. So no, I wrote 2 divided by 9. 2 divided by 9 is written like this in the bus stop method, and 2 divided by 9 is 0.222 recurring, and 9 divided by 2 is 4.5. So that's the other way around, okay? So don't get confused. So let's do another example. So we're gonna do 6 and then 5 like that. So we have to do 5 divided by 6. So in the bus stop method, we're gonna write this like this. So 5 divided by 6. So 6 goes into 5 0 times. Carry the 5. 50 divided by 6 is going to be 8. 6 goes into 58 times. Remainder is 2. And then 6 goes into 20. 6 goes into 23 times. Then 2 is going to be the remainder, and it keeps on recurring. So it's going to recur. And now we know that 3 is going to keep on recurring, as it's going to be remainder 2 again, it's going to be 3 again. So we're going to write it as 0.83 recurring. 0.83 recurring. Like that. Now the easy part of this is converting fractions to recurring decimals, okay? The easy part is converting fractions into recurring decimals. Now the hard part is when you try to convert the recurring decimals into fractions, okay? So let's do question number 4, as this is like more of like a question that might come on the higher paper. So we need to prove algebraically that the recurring decimal 0.8 recurring can be written as 8/9. Now, we know that we're going to write 0.8 recurring, I'm going to write it as x. We're going to say it's equal to x, okay? 0.8 recurring is equal to x. So then we can write that 8.8 recurring, 8.8 recurring is equal to 10x. Because if you multiply this by 10 and multiply this also by 10, you will see that we will get that. Because 10x is going to be 8.8 recurring. Remember this recurring sign above each of them, okay? So now, once we have done that, we can write this as 9x is equal to 8. 9x is equal to 8. Because we know that x is equal to 0.8 recurring. We know 0.8 is equal to 0.8 recurring is equal to x. So we know that 8.8 recurring is going to be equal to 10x. So then 8 will equal to 9x, okay? If you're getting confused by x and 10x, I just said that I just wrote it. We need to prove it algebraically. So I just wrote 0.8 recurring is equal to x. I just wrote it. And then we can see that 10x will equal to 8.8 recurring. We're going to multiply by 10, right? 0.8 recurring times it by 10 is going to be 8.8 recurring. And then if we subtract 10x by x, which is going to be 8.8 recurring, to minus 0.8 recurring, we're going to get 8. So 8 is equal to 9x, okay? Now, once we know that 8 is equal to 9x, we can literally get x on its own. We need to get x on its own. So what we do is that we're going to divide by 9 on both sides. We're going to divide by 9 on both sides like that. We're going to get x on its own. So we're going to end up with 8 over 9 is equal to x. And that is literally proving the point. Okay? So do you guys understand that? So why is it 9? So I'll go for another example. Let's go through question number 5. So they're pretty similar questions. So we know that 0.47 recurring, 0.47 recurring. We need to prove that it can be written as 43 over 90. Okay. So we know that 0.47 recurring. We're gonna say it's x. Okay. We're gonna say that it is x. 0.47 recurring is equal to x. We'll just say that, okay? So then we can write that if x is equal to 0.47 recurring, we know that 10x, when we multiply by 10, we are multiplying by 10. I look at it multiply by 10. We know that this will multiply by 10 as well. So we will get 4.7 recurring is going to be equal to 10x, okay? We're going to multiply by 10. We're going to move the decimal places to the left. That's how we multiply by 10, okay? Going to be 4.7 recurring, okay? 4.7 recurring is equal to 10x. And then we can multiply it by 10 another time. Why do we multiply by 10? It's because we want this to be a whole number. We need this to make it into a whole number, so we multiply it by 10. We need to make it into an integer. So then we can write it like this, okay, as a fraction. So as you can see, then what I'm going to do, since the denominator is 90, I'm going to try to make it into 100 because 100 is more closer to 90. So instead of 10, okay, so we're going to multiply it by 10 another time. Multiply by 10 another time. We're going to get 47.7 recurring is equal to 100x, okay? So whenever you are trying to convert recurring decimals into a fraction, what you do is first you will multiply it by powers of 10. And then once you've done that, you know that we will subtract 100x from 10x to get to 90, right? We will subtract 100 from 10 to get 90. So we know that 47.7 recurrence is equal to 100x, and we know that 4.7 recurrence is equal to 10x. So we can literally find out what 90x will be, right? 90x, because we know the denominator is 90, we need to make it into 90x. To get 90x, we need to subtract 100x by 10x. So 100x is 47.7 recurring, and 10x is 4.7 recurring. So we need to subtract them. So when we subtract them, these reoccurring, this reoccurring will equal to 0. And then 7 minus 4 is going to be 3. 4 minus nothing will give us 43. So we know that 90x will give us 43, okay? Now what we're going to do is we need to make x alone because we're trying to find out what x, the fraction. So we're going to divide by 90. We're going to try to make x on its own. Divide by 90 on both sides. And we will literally get 43 over 90 is equal to x. And that is proving, this is showing that it can be written as 43 over 90, okay? So, do you guys want me to go for another example? Or do you guys understand now? So, okay. Let's do this one when it doesn't tell you the answer, okay? Let's just do this one. 0.16 recurring, okay? And to convert this into a fraction. So gonna be the same method. So we know that 0.16 recurring is gonna be, we're gonna say it's x, okay? We're gonna say that it's gonna be equal to x. And then we can write what 10x will equal to, okay? So we're gonna multiply by 10 on both sides. And then we know that 10x will equal to 1.6 recurring, okay? Now what we're going to do, we're going to times it by another 10. Going to times it by another 10. So we're going to get 100x is equal to 16.6 recurring. Okay? No, now, what I'm trying to tell you is that whenever we're trying to convert a recurring decimal into a fraction, you always try to cancel out the decimal places. As you can see, we now know that if 100x has a 6 recurring as a decimal, and 10x also has a 6 recurring as a decimal as well. So if we do 100 minus 10x, you will know that these recurring decimals will cancel each other out. So then we'll get like a proper fraction. So that's what you're trying to get. You're trying to get the same recurring decimals. As you can see, we couldn't do 10x minus x because they are not the same decimal places, okay? So now we can literally find out 90x. We're going to subtract 100x by 10x. We are going to get 15. Because we do 16 minus 1, we're going to get 15, and the two sixes, the recurring decimal places are going to cancel each other out. Okay? Now, since we're trying to make x on its own, we're going to divide by 90 on both sides. Divide by 90 on both sides. And we're going to write it as 15 over 90 is equal to x. Now, this can be simplified. So when it's simplified, you're going to divide by 15, divide the numerator and the denominator by 15, and your final answer will be 1 over 6. Okay? Final answer will be 1 over 6. So, I want you guys to try question number 8. You guys try question number 8, okay? And please tell me the answer once you get it. I'll give you like a few minutes. How do we know if we will need to make it 90x? As I was saying, you either make it 9x, 90x, or 900x normally. But what you're trying to do is that you are trying to cancel out these recurring decimal places, okay? Trying to cancel out these recurring decimal places. As we can see, if we do 100x minus 10x, we will cancel these out. And that's what you're trying to do, cancel them out, okay? So, I'm seeing answers now. I'm going to give you like a few more minutes. I won't tell if you are correct because I want other people to try it. But yeah, these are higher paper questions. This is higher. GCSE higher. So let me quickly go through this question. So we are going to write. We have to write 0.27 recurring as a fraction. So we know that we can write 0.27 recurring. We're gonna say it's equal to x. Okay. Now we know that we can write this as 10x. So we're gonna multiply by 10 on both sides. Then it's gonna be written as 2.7 recurring is equal to 10x. And then we can write this as 100x, and it's going to be 27.7 recurring, okay, which is 100x. Now, as you can see, we have 27.7 recurring and 2.7 recurring. We can see that if we subtract these two, we will cancel the recurring decimals out. So we're going to get 90x. So 90x is going to be equal to 27.7 recurring, subtract it by 2.7 recurring. These recurring decimals will cancel each other out. It's going to give us 0, and then 7 minus is going to be 5, and 2 minus nothing is going to be 2. So we know that 90x was going to equal to 25. So then we have to make x on its own. It's going to divide by 90 on both sides. Divided by 90 on both sides. We're going to get 25 over 90 is equal to x. And we need to simplify this. We're going to divide by 5 from the numerator and the denominator. And we are going to get 5 over 18. Okay? How did I get 90? I got 90x because I did 100x minus the 10x. We're going to give us 90x. So I did the same for the other side. So I did 27.7 recurring, minus it by 2.7 recurring. So I got 25. So 25 is equal to 90x. And then you rearrange to find x. X is going to be equal to 25 over 90. So 25 over 90 can be simplified to 5 over 18. Okay? So now I'm gonna go do some harder ones. So I'm gonna do let's do it's easy. Let's do these ones. These ones actually are like can come from your exam. Okay? So when you see these types of questions, dividing recurring decimals, they aren't actually that scary. Okay? They actually aren't scary because first thing we have to do is convert both of those recurring decimals into fractions, and then we would divide them by the fractions. Okay? So first thing we're going to do is that I'm going to convert 0.39 recurring to a fraction. So we're going to write 0.39 recurring. We're going to write it as x, okay? I'm going to say it's equal to x. And then we'll write 10x, multiply it by 10, is going to give us 3.9. 3.9 recurring. And then 39 going there. So then we know that 100x we're going to be equal to 39.39 recurring equal to 100x. Now for this type of question, I would skip the 10x, as since we have two recurring numbers, so I will just start by multiplying by 100. So we get both of those numbers on the other side of the decimal place. Okay, we'll just times it by 100. And times it by 100. So once you have done that, what we can do is that you can see that we have the same decimal places, okay? We have 3 and 9 recurring as a decimal, and 3 and 9 recurring as a decimal as well, okay? So what we can do, we can cancel each other out. So we can get 99x, we can do 100x minus x, so we're gonna do 39.39 recurring, subtract it by 0.39 recurring, and then you are going to get 39.00. So we know that 99x we're going to equal to 39. And then what we can do is that we're going to rearrange to get x on its own. So to get x on its own, we're going to divide by 99. We divide by 99 on both sides. We're going to get 39 over 99 is equal to x. And then we'll simplify this to 13 over 33. 13 over 33 is equal to x. So this is just the first step. I'm literally doing the same thing that I did before. I'm converting 0.39 recurring. There are two recurring numbers, and I'm trying to convert them into fractions. As there are two recurring numbers, I would directly multiply it by 100. I'm not going to go to 10x, okay? I'm going to directly multiply it by 100x as the two recurring decimals, okay? And then I will get 39.39 recurring like that, okay? So 39.39 recurring is equal to 100x. Now then I highlighted that their decimal places, that 3 and 9 are recurring on both x and 100x. So we know that we can cancel them out. So the whole point of doing this is to cancel out those decimal recurring numbers, okay? To cancel those recurring numbers out, okay? So I got 99x. 99x is 39. I cancelled those recurring numbers out. So then I could write it as 39 over 99. And then you can simplify to 13 over 33. Okay? So we know that 0.339 recurring can be written as 13 over 33. Okay? Now, let's do the other one, okay? Now we need to convert 0.63 recurring to a decimal. To a fraction, sorry. 0.63 recurring. We're going to say it is x, okay? We're just going to say it is x. 0.63 recurring is equal to x. So then we know that 100x is going to be equal to 63.63 recurring. Okay? Now, once we have done that, we can see that these two decimal values can cancel out. The recurring numbers can cancel each other out, so that they have the same values, okay? So we can literally go and cancel them out. We're going to get 99x, okay? 99x is equal to 63. So then we're going to rearrange this to get x on its own. So we're going to get 63 over 99. We're dividing by 99. And then we know that we can simplify this to 7 over 11. Simplify the 7 over 11, okay? And now once you have found out those fraction values, what you're going to do, you're going to do the same thing, but we're just going to do 13 over 33, so 0.39 recurring, divide it by 7 over 11. Okay? Rub this out. Now, once you have done that, now you're going to use your method of division, dividing fractions. So you're going to keep this, change this, so I'm going to be 13 over 33, times it by 11 over 7. So we're going to get 13 times 11 is going to be 13 times 11. Let's see, what is that? 13 times 11 is going to be, let's use the calculator. 13 times 11, going to be 143. And 33 times 7, 231. And then we're going to simplify this. When you simplify this, you will get 13 over 21, okay? And that will be your answer, okay? So that will be your answer when you simplify this fraction. Yes, this is done calculator. But I just used the calculator because I didn't have any space to work it out. So topic. So by the way, if you want to follow along with me, you can use a free website. I have these questions from the free website called Math Genie. Okay, you can follow along if you want. So let's start from the base, and then we increase with difficulty as we go along. Okay. So is everyone ready? Okay, let's begin in 3, 2, and 1. Let's get started. So we know that we need to write the square root of 48 in the form k root 3, where k is an integer, okay? Where k is an integer. So we know that we can write the square root of 48 into 2, and like split it up. So we can write the square root of 48 as the square root of 16 timesing it by the square root of 3. So whenever we're simplifying surds, there is always a factor which is a square number. Whenever we're simplifying surds, there is always a factor of that specific number which is a square number. Literally always. As you can see, we have a factor which is 16 and a 3. 16 times 3. We can simplify the square root of 16. We can do the square root of 16. The square root of 16 is 4. So we're gonna write it as 4 times root 3, and we can join them together. We're gonna get an answer of 4 root 3. Okay? So k is 4. So I'm gonna do one more example. So we have to write the square root of 50 in the form k root 2. So we know that a square root of 50 can be written as can be written as the square root of 25 times the square root of 2. Okay? Now we know that we can simplify the square root of 24. We can actually do the square root of 24. The square root of 24 is 5 times the nearby root 2. So we're going to get answer of 5 root 2. I want you guys to do question number 3 and tell me the answer in the chat, okay? And now you have to look at this. There's a 5 in front of the square root of 27, so be careful when you do that question. So, let's see. If you don't get it, it's basically this, but there's an extra number on the outside. So I'll quickly go through it. So what we're going to do is that we are going to ignore this number on the outside because that's when people get confused. The first thing we're going to do is that we're going to focus on this root, the square root of 27. We're going to focus on this first, okay? Focus on the square root of 27. Do not forget about the 5, okay? Forget about the 5. Focus on this, okay? Focus on this. So we know we have to simplify this. We have to simplify the square root of 27. So the square root of 27 we can simplify it, right? We can simplify it to the square root of 9 times it by the square root of 3. 9 times 3 is 27. Now we know that we can do the square root of 9. The square root of 9 is 3, right? So we can write this as 3 root 3. So effectively, we can write this again. We are not going to forget about this 5. So we're going to write this as 5 times 3 root 3. Whenever there's a surd and a number together, it just means multiplication, okay? So we have 5 times 3 root 3. So what we do is that we're going to simplify this. We're going to multiply this 5 and 3 together. 5 times 3 is 15. It's going to be 15 root 3. And that would be your final answer, 15 root 3. So K is 15. So I want you to go through this question. Do question number 4 quickly. Yes, it's simple. It's really simple. If you know how to do it, then that's like easy marks you can achieve. What if it was, for example, 2 plus 3 root 3? Is this the max you can Yes, if when you're adding, you can't simplify it. Only multiplication you can simplify it. Okay? So the answer is 14 root 5. So I'm going to quickly go through it. So we know that we can simplify the square root of 20 to the square root of 4 and the square root of 5 multiplying each other together, okay? So we know that we can simplify the square root of 4 to 2, okay? Then we're going to write 2 root 5 like that. This is higher. Surds is higher. 2 root 5. Now, the surds are grade 7. So 2 root 5. So then we're not gonna forget about the 7 on the outside. It's gonna be 7 times 2 root 5. So we're gonna multiply these two numbers on the outside. It's gonna be 14 root 5, and that will be your answer. Um, we only use the factors whenever there's one of them. One of them needs to be a square number. Whenever we are trying to simplify thirds, one of those factors need to be a square number. Otherwise, it won't work. Okay, because we're trying to simplify. As you can see, in this one, the 9 was the square number, so we can simplify it to 3. Here, 4 is a square number, so we simplified it to 2. Over here, 25 is a square number and simplified it to 5. Okay. Now this is the easy part. This is the easy part of the surds, simplifying them. Now this is when the hard parts come, expanding them out. Okay. So we need to expand and simplify this. Expand and simplify this. So I'm going to zoom in. So we have to expand and simplify this, okay? So whenever we're expanding, we're going to do it like we usually do in like algebra, okay? So we're going to do 2 times 2. So what is 2 times 2? 2 times 2 is 4. Okay? And then we're going to do 2 times negative root 3. 2 times negative root 3, we are going to get negative 2 root 3. Okay? So whenever we're multiplying a number by a third, you kind of just join them up. And then we're going to do root 3 times 2 is going to be positive 2 root 3. And then, now, this is when people mess up. So we know that there's a root 3 multiplying by a root 3. Multiplying by a root 3. But this root is negative. Now, whenever we have two roots together and you're multiplying them, the roots cancel each other out. Okay? The roots will cancel each other out. And you will get negative 3, okay? Get negative 3. So then, you know that these will cancel out. So we know that this minus 2 root 3 plus 2 root 3 will give us a 0 when you add them together. Then we do 4 minus 3, we will get 1. Okay? Now this is a negative root 3, okay? This is a negative root 3. That's why you're going to get negative 3, okay? You always need to look at the symbol in front of it. Yes, when you times the same roots. But this over here, we are doing root 3 times negative root 3. So the answer is going to be negative 3. Literally. Okay? So, okay, if you don't understand, it doesn't matter because I will go through another question which is going to be very similar to this, okay? So, what I'm going to do is that we are going to do this question. So, we know that we have to do 3 plus root 5 squared. So, whenever we're squaring a bracket, it's just that bracket 2 times, okay? So, we're just going to do this. 3 plus 5 root 5. Now, this will kind of make sense now. Because now we don't have those negatives, okay? So we're going to do 3 times 3. 3 times 3 is 9. It's going to be doing normal expanding brackets, but with surds, okay? 3 times 3 is 9. Now I'm going to do 3 times root 5. 3 times root 5 is 3 root 5. We're just smashing them together. If that's a mathematical term. Going to do 3 root 5. 3 times root 5 is going to give us 3 root 5. And then what we're going to do is that we're going to do root 5 times it by 3. It's going to give us 3 root 5 again. And you always need to remember the number goes in front of the surd. It doesn't go after the surd. This big number goes in front of the surd. And then we're going to do root 5 times root 5. The roots are going to cancel out. And we're going to get a plus 5. Okay? This is grade 7, okay? Grade 7. So once you have done that, we can simplify this. Now first, we're going to simplify those integers first, then we're going to simplify the surds. So we know that 9, we can do 9 plus the 5. 9 plus 5 is going to give you 14. Okay, now plus. Now can someone tell me how you would simplify the surd? How can you simplify the surd? So you would just add these two numbers together. So it's gonna give you 6 root 5, okay? Gonna be 14 plus 6 root 5. In the question, it's said to give this in the form a plus b root 5. So 14 is a and 6 is b, okay? So, does this make sense now? Does that make sense? Okay, that's good to hear. So, let's do another type of question. Let's do rationalizing, okay? Rationalizing. So, rationalize the denominator 6 over root 3, okay? This is called surds, okay? Mark, this is called surds. So, rationalizing surds, or it just means getting rid of the root sign. So when it means rationalize the denominator, it just means that we need to get rid of this surd. We need to get rid of the surd sign, the square root sign. So what we do is that we multiply it by the denominator. So we're just gonna do times the we need to times the denominator by root 3 and the numerator by root 3 as well, okay? So, rationalizing the denominator just means getting rid of the root sign, okay? Getting rid of the root sign. So, what we're going to do, you guys know that when we multiply two roots together which have the same number on the inside, the roots cancel each other out. So we're going to do the same. So we're going to times it by root 3 and times the top by root 3. So we're going to get 6 root 3 over 3. Okay? As you can see, we have got rid of the denominator with the surd. Okay? Now what we're going to do is that we are going to simplify this. So you do 3 divided by 6 divided by 3, we're going to get 2 root 3. Okay? And that will be our answer. So I want you to rationalize this one to x over root x. This is basically the same, but it has x's. So don't get confused. I want you to try this question over here. Try question number 11, guys. Give the answer in terms of x. Like, yeah. So, the answer is the square root of x. So I'm going to quickly go through it. So, we have x over root x. We need to get rid of this square root sign, so we're going to multiply it by the square root of x by the denominator and the numerator, and then you're going to get x root x divided by x, and then these two will cancel out, and we're going to end up with root x. Okay, so why do you multiply it by the root x? It's because we are trying to get rid of this surd sign. So we're trying to get rid of this right here. We're trying to get rid of the square root sign. To get rid of the square root sign, you know that if you multiply it by the same surd, you will cancel out the square root sign, right? So you just do that by the numerator and the denominator, because if you do something to the denominator, you would do the same with the numerator, okay? So I'm gonna go through a more complicated question, which just involves all the skills that you just learned. It just involves all the things you just learned into like one. So we'll combine everything. Okay, so let's do question number 16. We're gonna do question number 16. Okay, it doesn't look it kind of looks long, but it's actually very simple. It's worth 3 marks. So question number 16. And this is gonna be the last question before I end this live, okay? So we have 3 root 3 plus 3 over 3 plus root 3. First thing you have to do is that we're going to rationalize this, okay? We have to rationalize it. But before we do that, we're going to rationalize it by the negative, okay? We're going to do it we're going to times it by 3 negative root 3, okay? And do the same from the top, okay? We're just doing it because we have like a number next to it and you want to like cancel it out basically. But yeah, that's what we're going to do. And then you're going to multiply them together. So I'm going to write them together, okay? I'm going to write them together. So it's going to be 3 root 3 plus 3. And then 3 minus root 3 over 3 plus root 3 then 3 minus root 3. And then when you expand this out, you will expand this out. Let me rub this out. Gonna expand this out. So when expand this out, expand the bracket like I did over here. Over there. So we are rationalizing it. Okay? We're just rationalizing the denominator, but we're just doing the negative rationalize because we have a number with it. So we're gonna do the same thing. We're gonna multiply by the denominator, but change the sign, swap the signs, because you want to get rid of the number as well, okay? Why is there two lots? It's because we just put them into brackets, okay? So we have this multiplied by this number, the denominator and the numerator, okay? So now, once you have done that, you will expand it like you will usually. So now it's gonna be 9 root 3 minus it by 3 times, it's gonna be 9. 3 times 3 is 9. And then plus 9, then minus 3 root 3 over 9 minus 3 root 3 plus 3 root 3 minus 3. Now you can see that you can literally see that why we multiply by the negative, okay? Why we multiply by the negative. As you can see, this will cancel out. This will literally cancel out. That's why we multiply it by the negative, okay? So now, when we simplify this, you will get 6 root 3 and over 6, because this will cancel this out. 9 minus is going to be 6. Then when these two cancel each other out, then we do 9 root 3, subtract it by 3 root 3, you get 6 root 3, okay? So what we're going to do, we're going to simplify this even further, so our answer is going to be root 3, okay? And that is going to be proving our point, because it says the answer can be written as root 3 over here, okay? When do I do my lives? I start my lives at 6 o'clock every single day on the weekdays. So Monday to Friday, I do lives at 6 o'clock. And then on the weekends, I do it at 5. So yeah. So that will be answer, okay? Why is there two lots? As you can see, we are multiplying the whole denominator by itself. We're trying to multiply the whole